Hello. My name is Barthel, and I would like to talk to you about a new idea for image searching that we've developed. I'm CEO of Pixolution, and I'm also professor at HPW in Berlin. You're all familiar with the problem of image search. This is the normal way you would do it. Usually you type in the keyword, and then after you've typed the keyword, you would have a long list of different images. And usually all these images are mixed up. They have thousands of them on different pages, and usually they are unrelated, and it's pretty difficult to find something. Usually it takes hours if you're really looking for something specific, and it can take very long until you found it. Recently, some companies came up with visual similarity search systems, and this is actually the result from Bing. I have been searching for golf, and then I might just look for one image and say, find me something that looks similar. If I take this image here, this is what actually Bing does. And you can see there are some duplicates, but there are also some images that totally are wrong. Because sometimes if images look similar, it doesn't mean they have a semantic relationship. And the other way, if they have a semantic relationship, very often doesn't mean that they look similar. There have been very powerful techniques, recommender systems for selling products. You know all this from Amazon. If you buy something at Amazon, they're very good suggestions, but up to now this has not been used for image retrieval because it's pretty hard, mainly because there are far too many images. There are other reasons as well. We have developed one technique which is called visual sorting of images. Actually, you can see these are more than 800 Eiffel Tower images from a Google search. And this is the original order from Google, so we didn't actually mix them up, but this is the order from Google, and you can actually not see anything at all at this scale. But if we rearrange them by the visual appearance, it will actually look like this. And now you can still not recognize the images, but you can see where are the areas that are interesting for you, and actually you can zoom that area, and then you can actually check if these are the images you like. This is just another example that I got from Nathaniel. So these are 7,400 images, unsorted. If I sort them, they look like this. It doesn't really help you, but if you zoom in, you can see you get similar looking things close to each other, and this might help you finding things. Okay, what did we do? We basically put together all these four parts, but the most important thing is that we don't rely on the metadata that is on the images. This means file names or database entries, things like that. What we want to do is we want to gather information from the user. And how do we do this? We do this basically by tracking his search interaction. And we also propose not to have this endless list, but we rather propose a visual browsing technique, so I'm going to show you. So this is conventional image search. This means you have a keyword, you got to go to the system, and you got to come back with a small result set. This is our system. The main difference is that in the very, very beginning, we start with a larger result set, so it's visually sorted. From that set, you got a pretty high chance that we might find something that is similar to what we're looking for. We can take that, look for other images that look alike, and then actually we iterate this process. We click on images that we like, and if you like them, we get others like them, and it's actually a process. And during the process, we are actually learning image relationships. So this is a small movie showing this. So these are actually the same images from before, these Apple images, and actually all I do is just double-clicking on images I like. And I can see that I gradually come to other images. For example, if I'm looking for red images or red apples on trees, we'll have something like that. And if I decide to have something rather with a white background, I might click on something like this. And then you can see very quickly I can come to the result like this, which would be very hard in a normal way. How do we learn image relationships? So what you're seeing now are different lines from different users. So everybody might just click different images. But usually, in most cases, they are somewhat related in useful cases, so there wouldn't be people just clicking wildly around. This would be something like this, so these would be different colors would be different users, and after a while what we get is a kind of weighted network of images. And from these weights, we can actually find out which images are connected. And this is actually how these connections look like. So this is just a demo from a system that we've developed called Pixelu. And you can see, if I spread the radius and look how the images are connected, you can see that they are nicely connected. And most of these connections are very useful. And this means we have all this information was only gathered by people that did use the system. And we found quite good relationships here. Well, what's the advantage about the new system? The main thing is that actually The users help to clean up the data. This is totally new, because normally it's the other way around. You get all your data, you try to arrange it in a nice way, but now the user does the job for you. And the nice thing is, the more often it's used, the better the results will get, because it's learning on the fly as you use it. And the nice thing as well is you can actually find things you couldn't find in previous systems. For example, this blue horse down there never would have been found with a visual system because it has just the wrong color. But if you look at it, it's perfectly correct. It could also be a dawn image. So this is the end of my talk. I just want to mention that we have also developed an app for the iPhone and the iPad, which does one part of that, only the sorting, and the rest is going to come. So if you're interested in that, please have a look for Visolo. Thank you very much.